Hi everyone. Today we're gonna go through a little bit of kinematics. So you have already seen a little bit of this in class the other day, and I promise that I'm gonna make a video so that you can watch it again and again and again if you do want to. So the example that I'm gonna go through is about an object that moves in a straight line, and position of this object from the origin is given by this equation here. So this one in red. So and displacement function is in kilometers. Time taken is in hours, and time is bigger or equal to 0. So what I would like to know, actually, I'm going to change this question a little bit. Instead of an object moves in a straight line, so what I'm going to do, I'm going to say not an object. So I'm going to go with Miss B moves in a straight line. So as you do know, I like going for a walk, so walks. So, and this is my position from the origin. I'll write here Grange. Okay, Grange is a lovely place, and an equation is still going to be the same. S of t equal to t to the power of 3, take away 6t to the power of 2, plus 90 and take away 1 kilometers, and time is going to be in hours. So what I would like to actually find out is what is going to be the total distance walked in the first 3 hours. So as you know, I can walk for many hours, but I just want to see what's going to be in the first 3 hours. And I don't know if I'm walking with my friend Marina or my husband, so I guess that's gonna, once we find out the distance walked, I think I can make a conclusion who was with me. Not that I don't know, but yeah. Okay, let's start. Find expression. So in order to know this distance, walked, so I guess I would need to know the velocity. So, how fast I'm walking or how slow, and direction, so which way I'm going, and also, the rate of change of velocity, which is acceleration. First, I'm going to find the velocity, and velocity is first derivative of displacement. So s dash of t is equal to velocity, and find first derivative. So it's 3t to the power of 2 take away 6 times 2. Okay, t and take away 9. So I'm just going to put units here for now, and in hours, and we're going to find when velocity equal to 0. So 3t to the power of 2 take away 12t take away 9 is equal to 0. Only when t is equal to 1 and t is equal to 3. So I'm not going to go through solving this quadratic equation. So it can be solved, using different methods. Maybe the easiest one is graphics calculator. So, but if you do want to know how to solve it by factorization, you can go to quadratic equation folder, and there is one video on how to solve quadratic using factorization. So the next step that I'm gonna do, I'm just gonna step 1, yeah. So the next thing we're gonna do is to find acceleration, and acceleration is first derivative of velocity, the rate of change of velocity. So first derivative is gonna give us 6t take away 12, so that's gonna be kilometers per hour squared. So, and this is equal to 0. So it's equal to 0 when t is equal to 2. So again, the same way, I'll solve it. I'm just gonna draw this a little bit. Yeah, okay. Just get rid of that. So t is equal to 2. And I'm gonna add here that this is equal to acceleration, a of t. So now we do have equation for this velocity, which is this one here. So that's our velocity equation, and acceleration one. So it's here. So the next step I'm going to do is actually to draw a sign diagram. So sign diagram is the next step. So I'm going to put number 2 here. So sign diagram for both functions. So sign diagram. So the first one is going to be velocity. So as t is bigger than 0, so we are not interested in anything less than 0. So, and velocity is equal to 0 when t is equal to 1 and t is equal to 3. Now, in order to find the sign of this function, is it positive or negative before 1, before 1 hour, is it positive, negative between 1 and 3, and what's happening after 3. So you already know, you have seen that before. In order to find the sign here in this area, so we have to choose a number that is less than 1. So you can choose 0.5, 0.7, you know, whatever number, and substitute in your equation. So substitute in this equation, and actually when you do substitute, it's going to give you a number that is positive. So I'm not going to choose a number, but you can give it a go and see if you're going to have a positive answer. Then to find the value of your velocity between 1 and 3, you do the same. You choose a number here between 1 and 3. You don't choose 1 or 3 because velocity is equal to 0 at these points. And if you choose number 2, it's going to give you a velocity negative number. So we're just interested if it's positive or negative, and same happens after 3. So you can pretty much choose number bigger than 3, substitute in the same equation, and it's going to give you plus. So I'm just going to tidy up here these lines. Yep, get rid of that. Yep, and maybe I'm going to label this sign diagram and say this one is for velocity sign diagram. The next one I'm going to draw is acceleration one. So similar, let's be consistent with colors. So again, not interested in t less than 0 line. So t is equal to 2. So somewhere here in the middle, so it's 2, and same. So now we're looking, you know, is it positive or negative? So before 2, you choose a number between 0 and 2, substitute this number into your acceleration function, which is here. And for example, if we choose number 1, 6 times 1, so 6 times 1 is 6, take away 12, it's negative number, so it's negative here, and if you choose number bigger than 2, should give you positive. So this is now sign diagram for those two functions. So the other thing that we're gonna need in order to see the total distance walked is actually we have to find the initial conditions. So what does it mean, initial conditions? So we have to find what is happening when time is equal to 0, where actually am I stationed, and which way I'm gonna go, what direction I'm gonna go to. So the next thing, so it's gonna be initial values. Just gonna move this, or maybe go to the next page, see how that's gonna go. Slide. So, and I'm gonna look at sign diagram and see if the speed is increasing. When is speed increasing? Let's just focus on speed increasing. So what do we know about speed increasing? That sign diagram for velocity and acceleration have to be the same sign, either positive or negative. So either positive or negative has to be the same. Looking here, so looking at this one here, so looking here, it's positive, and this one is negative, so we are not interested in anything below 1 because they have different signs. But then we can see from 1 here, if I have 1 there, so let me just put small 1 here, like 1 here, then I can see from 1 here, from 1 to 2. If I have 2 here, let's put 2 there. So we can see that actually the signs of velocity and acceleration functions are the same. So it's this area. So it is in this area blue. Okay, so it's in here. And let's just check other values. What's happening after 2? After 2 here, it is, this one it's negative, this is positive until we reach 3. So I'm just gonna add number 3 there. 3. And then after 3, I can see here they have the same sign. They have the same sign. So this time is positive. So I'm gonna blue, okay, it is positive. So based on this and what we said before, so for speed to increase, velocity, and acceleration have to have same sign. And that is happening in this area, so in those 2 values. So I'm just gonna write here above, okay, speed increasing in this area. So speed is increasing when t is bigger or equal to 1 and less or equal to 2. So this is this area here. Now let's have a look at this one here. So that would tell us when t is bigger or equal to 3. So, and speed is increasing. And I think that would be all for today. Bye. Next page, that's good. So I'm gonna find, that's gonna be step 3, isn't it? Yeah, 3, number 3, let's go back to blue. So 3, when time is equal to 0, so we are looking for initial conditions. Initial conditions. So we're gonna go with S of 0 equal to, substitute t equal to 0 into your original equation, and it's gonna give you -1, and it's gonna be kilometers. So again, substitute t equal to 0 in velocity function. When you substitute, calculate, should give you 9 kilometers per hour. And the last one, acceleration one, same. Instead of t, you put 0, you replace t with 0, and it should give you -12 kilometers per hour squared. So we do have initial values. So so what's happening here? Looking at this graph, so we're looking, okay, S of 0 is -1, so which means that if S of t is less than 0, then it means that the object, in this case me, is 1 kilometer to the left from the origin, which is Grange. So I'm just gonna have a small look. Here's Grange, and I am 1 kilometer to the left, so which is -1. So I'm here. And velocity is 9, it's positive, so, and that is gonna tell me, am I gonna go to left, like more in direction of Henley or Glenelg, for example? Am I going that way? Or if I'm going to the right towards the semaphore. So, and because it's positive, it does look like I'm going like towards semaphore. So it looks like I'm going this way. And acceleration is negative. So it's -12. So we have realized that, I think that would be the next step. What we have realized that actually velocity does change sign when t is equal to 1 and when t is equal to 3. So which means that velocity is actually what? Is changing direction. Okay, I'm just going to write this. Is changing direction. It's changing direction. So, at these times. So now we do have to consider those values and see where actually I will be at those times in 1 hour and 3 hours. So I do know where I'm going to be at initial, like in the beginning of my walk, and then where am I going to be in 1 hour. So, and then where am I going to be in 3 hours? So now I have to go back to displacement function because that is going to tell me, so, and substitute. So instead of t equal to 1, substitute the values and it should give you 3 and s of 3. So I'm not going to go through substitution. So instead of t, every time you see t, you replace with number 3. But please check if you do have the same answers. So n is equal to 1. So I do have some values here. So and it does look when I do change direction that I'm gonna be 3 kilometers to the right of the origin, and then when it's 1 kilometer, I would be to the left of origin, or something like that. So the best way to actually see what is going on here is to draw like sort of motion diagram. So I'm going to call it motion diagram. It's going to be my number 5, motion diagram. Okay, motion diagram. So I'm going to have a line here, like that, line here. So, and this line does represent position. Okay, position. So, and what do we have here? We have origin. Origin, what did we say origin is going to be? We said Grange. Grange is going to be origin. Lovely place. Grange. And I'm going to put this origin. It's not 0, it's origin. So, and let's look at some numbers. Do you remember what happened when t is equal to 0? So it's up here, isn't it? So let's go with green. -1. So we do know if displacement function is less than 0, then it means that we should be to the left of the origin. So in this case, it's -1. So we would be 1 kilometer to the left from the Grange. So I'm guessing that could be Henley Square. So, and this is, I'm just going to have dot here, time equal to 0. So I'm here, okay? So I'm at Henley Square. Let's write Henley Square. That's usually where I meet my friend. Henley Square. So, and now the next thing that we're gonna look at is what is happening, in the next hour and 3 hours. So, when t is equal to 1, did we calculate that? Yes, we did. So, when t is equal to 1, my position is gonna be 3. So, and because it's positive, before that, so t is equal to 0, and now from here, I know I'm moving to the right because velocity is positive. So I'm moving this way. So I'm still moving, and in 1 hour, I will be 3 units, looking at this one here, I will be 3 units to the right. So it's 1, 2, 3. So I'm gonna walk. So what is 3 kilometers from Grange? It could be West Lake Shore, could be Semaphore South, something like that. So, and then I do know at this time, at this instant, that velocity is changing direction. So, and we can see that this is after 1 hour, isn't it? Yes, 3 kilometers. And then what is happening here is changing direction. So I guess it has to go like this way, isn't it? So, and when s is, the time is equal to 3, s of 3 is equal to -1. Now, time is equal to 3, so time is equal to 3, and we have to be at -1. It does look like, I'm going to be back where I started. So, and yeah, I will be there. So, and then it's changing direction again, and it's going, I'm going to use, changing direction again, and it's going, that way. So, this is pretty much motion diagram. So, and what I'm actually interested in is just to see the total distance that we have walked, or I have walked in the first 3 hours. So how I'm gonna do that, so I'm gonna look at this graph, and I do know the initial point start. It was where I started was Henley Square, so that was 1 kilometer away from Grange. So, and then I walked, what color should I use? Yellow, so, and then I walked from here, so that is 0, from -1, that's 1 unit, then 1 more, and then 1 more, and then 1 more. So it does look like 4 units, isn't it? Okay, so total walk, okay, yeah, let's go this, okay. That's not the best color to use. Okay, I'm just gonna go with that. Yeah, doesn't want to write. Yeah, okay, much better. Total walk is equal to, so we said 4, and then I change direction from here. So, and then walk back to Henley Square. That is plus 4 units. So it does look like 8 kilometers. 8 kilometers in how much time did we say? So it was in the first 3 hours. So in 3 hours. It's like, wow, okay, in 3 hours. Based on this, it does take 3 hours to walk 8 kilometers, because when I walk with my friend, we sort of walk fast. So I have feeling, my husband was with me, because when he walks, he does enjoy views, so, and it does take time. So I think this would be all for now, or I could actually just talk a little bit about speed before I let you go, and see if speed is increasing. We do know speed is increasing or decreasing, but let's just focus and to see when actually the speed is increasing. So for that, I'm gonna go back to the